Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 34 to 37 of the Algebra 1 New York Regents Common Core exam for January 2016. All right, let's take a look at question 34. That reads, Fred's teacher gave the class the quadratic function f of x equals 4x squared plus 16x plus 9. State two different methods Fred could use to solve the equation f of x equals 0. All right, there are various methods that can be used to solve a quadratic equation, but we're going to play it safe here. We're going to pick two methods that always work. Now, what two methods are those? Method one is completing the square. All right. And then method two is basically completing the square, but it's the condensed version of completing the square known as a quadratic formula. Quadratic formula. Okay. So one thing you want to note is that these two methods always work. Okay, they always work when you're solving quadratics. Okay, you can use factoring if b squared minus 4ac the discriminant is a positive perfect square. Okay, let's write that down. The factoring method. A factoring is just a side note. Factoring method can be used if b squared minus 4ac is a positive perfect square. Okay, so that radical component of your quadratic formula will actually become an integer, and then all you have to do is deal with rational numbers. Okay, so we can do the check in this problem, for example, to see if factoring could work. So can you factor the related quadratic equation of this function? Well, let's just test it on the side here. A is 4, B is 16, and C is 9. Okay, is in standard form. So let's see, what is b squared minus 4ac? If it is a positive perfect square, then you can solve by factoring also. All right, let's just test it out. So we're going to have 16 squared minus 4 times 9. Okay, so let's plug that into our calculator. We have 16 raised to the second power minus 4 times 4, which is 16 times 9, which automatically makes this product bigger than that, since, well, actually smaller, since this is 16 and 9 is smaller than 16, so smaller, so it's fine. Okay, so it's going to be positive 112. Now, is 112 a perfect square? Easy way to check is just try and take the square root of 112. Let's see if we get an integer. We do not get an integer, so that's not a perfect square. So the discriminant here is 112, which is not a perfect square. Okay, 112 is not a perfect square. It's positive, but it's not a perfect square. Okay, so you cannot solve by factoring. Okay, but the quadratic formula and the completing the square method always works. Okay, so keep that in mind. Okay, the B part, it says using one of the methods stated in part A, solve f of x equals 0 to the nearest 10th. I will recommend you use the quadratic formula because, as indicated earlier, it is the completing the square algorithm in condensed fashion. Okay, so completing the square involves too many steps and it's easy to make mistakes, so it's better to just use the quadratic formula. Okay, so let's write down the quadratic formula. So the hard part about remembering about solving using the quadratic formula is remembering the formula and writing it correctly. Okay, there's a quadratic formula song. You can sing it when solving it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can just sing that quadratic formula song. That can help you remember it. There are many other songs out there, but it's critical that you know your quadratic formula. Okay, now we need a, b, and c to substitute in here, and then we will simplify. Okay, so a is for the coefficient of x squared, b is 16, the coefficient of x, and c is positive 9. All right, so let's proceed to solve it. So x equals, now if any of these terms are negative, then you definitely want to use a parenthesis when carrying out the substitution. Okay, so we don't have any negatives here, so we're fine. So we have negative b, negative 16, plus or minus the square root of b squared, 16 squared minus 4ac, 9, and this entire expression divided by 2a. Now, one mistake students make is they divide only the radical piece by 2a. That's incorrect. You divide the entire expression on top by 2a. Okay, now you want to be really careful when carrying out your arithmetic simplification. So we have negative 16 plus or minus. Now we've already computed the value of the discriminant, right? We did it before. We found out it was 1/12. And now we're going to divide that by 2a, which is 8. Now in this problem, we're asked to find it to the nearest 10th. So we have to actually carry out a decimal approximation of what the square root of 112 is. Okay, so I think we already have that. Let's call it back up. 10.5830. So that's what we're going to be using. So x equals negative 16 plus or minus 10.583, and this entire thing divided by 8, which is 2a. So we have to specify what our two roots are, our two solutions. So the first one is going to be the negative one. So we're going to go negative 6 minus 10.583 divided by 8. That will give us the first root. And then we are going to then evaluate, figure out what negative 16 plus 10.583 over 8 is. Okay, let's write that down. 10.583 divided by 8. Okay, because of the decimal involved, we want to just plug that into our calculators and have the calculator do the heavy lifting for us. All right, so let's do the first one. Now, since you have multiple terms in the numerator, you want to make sure you use parentheses appropriately. So negative 16 minus 10.583. Close the entire numerator divided by 8. Negative 3.322. So negative 3.322. Let me see, 3228. So 3229. That's the first one. And then the second one, second answer is, I'm just going to recall my previous entry and switch the minus 10 to plus 10, since that's the only difference. And our answer is negative 0.6771. Negative 0.6771. All right, the problem calls for us to round it to the nearest 10th, or just one decimal place. So we're going to have x equals negative 3.3 and x equals negative 0. Rounding this, well, 7 is bigger, is 5 or greater, so we add 1. So this becomes 0.7. Okay, so those are our two answers. All right, let's take a look at problem 35. It reads, Erica, the manager at Stellar Beans, collected data on the daily high temperature and revenue from coffee sales. Data from 9 days this past fall are shown in the table below. So you have the data set provided. Question, state the linear regression function f of t that estimates the day's coffee sales with a high temperature of T. Round all values to the nearest integer. So the linear regression formula is of the form, so linear regression form is, in this case, our independent variable is t, so it's going to be of the form f of t equals at plus b. Okay? All right, so we're going to use our calculators to carry out this linear regression determination and analysis in the second part. So fire up your calculators, go to statistics, and then edit. We're going to enter these two rows into the columns in our calculator. L1 will represent our independent variable, the time, and then L2 will be our coffee sales, a function of time. All right, so let's go ahead and enter it. So we have 54, 50, 62, 67, 70, 58, 52, 46, and 48. Okay, so let me go over it again just to make sure I entered everything correctly. All right, starting from the first entry, 54, 54, 50, 62, 67, 70, 58, 52, 46, and 48. Excellent. So let's go to the second row, our function of time, our coffee sales values. All right, so we have 2900, 3080, 2500, 2380, 2200, 2700, 3000, 3620, 3720. Okay, let's go and check again just to make sure everything is correct. So 3720, 3620, 3000, 2700, 2200, 2380, 2500, 3080, 2900. Perfect. So now we're going to go to our catalog, and I'm going to turn on diagnostics. Okay, so let's see. Let's go to catalog, and I'm going to go to D. Where is D at? Here. And then scroll down. I need to turn on diagnostic on, enter, enter. Calculator tells me done. I'll go back to stats, and then I'm going to go to the calculate option, and then I'm going to calculate linear regression of the form ax plus b. Okay? I think there's another format. There's another expression here, a plus bx. So please pay close attention to the format you're using, or else you're going to ruin the result. So we're going to use this format right here, ax plus b. All you do is just press enter. It calls up the linear regression calculator. Press enter again. Bam, there goes your answer. Okay, so our linear regression function, we know that A is equal to, what was A? Nearest integer. Okay, so we're rounding to the nearest integer. So it's going to be negative 58 to the nearest integer, and B to the nearest integer is going to be 6,182. Okay, so our linear regression function is of the form at plus b. So all we'll do is plug in a and b into this function, and then our final answer will be f of t equals negative 58t plus 6,182. There goes your linear regression function. Okay, now let's take a look at the second part. It says state the correlation coefficient R of the data to the nearest hundredth. Does R dictate a strong linear relationship between the variables? Explain your reasoning. Okay, so one thing you want to recall is that equal is that the closer the correlation coefficient, the closer the correlation coefficient R is to 1 or -1, the closer it is to 1 or -1, the stronger the correlation. Okay? The stronger the correlation. We talked about this earlier in in one of the other installments of this review series. We said we basically represented the scenario with a number line, and then we said, okay, you have 0 at the center, and then you have 1, 2, 3, 4. So this is 1, and this is 1, 2, 3, 4. This is -1. The closer you get to -1 or 1, the stronger it is. Okay. Whereas the closer you get to 0, the weaker it is. So at the center is weak, and then here is strong, and then here is strong. If you're at 1, that's perfect correlation, 1 or -1. Okay, so let's keep that in mind. Now, what is our correlation coefficient? Just go back to the calculator. R is our correlation coefficient, so 0.94413. So R is actually -0.94413. We're asked to round to the nearest hundredth or to 2 decimal places. So R is -0.94. Okay. Now, what kind of relationship does this result indicate? How does where is 0.94 in this continuum that we have here? Is it close to 1 or -1? The answer is yes. 0.94 is somewhere here. It's close to -1. So since it's close to -1, it indicates a strong linear relationship. Okay. So let's write this down. Since R, which is equal to -0.94, is close to -1, that indicates a strong linear relationship. So basically, the data sets will look very much, they'll fall in the shape of a line. All right, so that's that. All right, let's take a look at question number 36. It reads, a contractor has 48 meters of fencing that he is going to use as the perimeter of a rectangular garden. The length of one side of the garden is represented by X, and the area of the garden is 108 square meters. Question, determine algebraically the dimensions of the garden in meters. Okay, so what's the length and what is the width? That's what the question is asking. Now, a real quick tip I would like to give to you concerning solving algebra problems that involve geometry is that whenever you're solving an algebra problem that involves a geometric figure and the problem is presented in text format such as this, it's very wise for you to give yourself a diagram. Okay, draw a nicely labeled diagram. It will assist you in having a visual perspective of the problem and also aid you in labeling the problems and breaking it down into its the respective components. Okay, so we're going to follow our advice and we're just going to sketch a rectangle because that's what we're dealing with here. Okay, so we're going to be dealing with the area and what else? The perimeter. Okay, so in order to do those two, we need to label them. So let's call this the width and that the length. We're told in the problem that one side of the length is X, so we can call this X. Okay, now let's go ahead and break this problem down into two parts, the area equations and the second one will be the perimeter equations. Okay, let's start with the easier one, perimeter. Okay, so what is the formula for the perimeter of a rectangle? Let's write that down first. So formula for the perimeter of a rectangle is 2 lengths. So you add these 2 lengths plus 2w at the top and bottom width. Okay, so there you have it. How about area? For area, what is the formula for the area of a rectangle? Formula. So the area of a rectangle is simply given by length times width. Okay? Now we're going to be filling in these equations with the information that are provided to us. Let's start with the perimeter information. We're told in the problem that the perimeter P is 48 meters. The length is X, and the width is just W. We don't know what that is. All right. So using this information, substituting these values into this equation, we end up into this formula. We end up with the first equation: 48 equals 2 length. L is X, remember, plus 2W, 2W. Okay, so this is our first equation. Now let's take a look at the area situation. We are told in this problem that the area is equal to 108. The length is X and the width is just W. So putting in these values into this formula right here, we're going to have the area, which is 108, equals the length X times the width, XW. Okay, so what do we have now? We have a system of equations. So let's go ahead and write it down. We have write it as 2x plus 2w equals 48. That's equation 1. And then we have 108. Or I can write xw equals 108. Since these two equations, this is equation 2, are in different formats, it will be wise for us to use substitution method, since elimination will be difficult since this has two variables and we don't have any term with x and w in equation 1. Okay, so we're going to use substitution method. Substitution. Okay, so now we're going to isolate a variable in one of the equations and plug in the value of that variable into the other equation so that we have only one variable in one of the equations. Okay, so I'm going to start with the second equation from 2. We have xw equals 108. Now I want to isolate w and then plug in the value of w into equation 1 and then solve it. Okay, so how do I get w isolated here? I simply divide both sides by x. So we have w equals 108 over x. All right, we can call this equation 3. Now what we're going to do next is we're going to substitute 108 over x for w in the other equation. Remember, this came from 2, so we're going to plug it into 1. Okay, so substitute 108 over x for w in equation 1. So equation 1 is now going to become 2x plus 2 instead of w. We plug in that value we're substituting in that we got from equation 2. Plug that into equation 1 equals 48. Now take a look at what we have. We have one equation and one unknown, or one variable, so we can totally solve this equation right here. So we have 2x plus 2 times 108. You can put this over 1, multiply across. We have 216 divided by x equals 48. Now to clear out this x in the denominator, I can multiply my entire equation by x. Okay, so multiply the left side by x and multiply the right side by x. So that yields 2x squared plus, when you distribute the x at this term, the x's cancel out, plus 216 equals 48x. Okay, let's pause for a second. What did we just accomplish? We just got rid of the x in the denominator, which is perfect. Now we have a quadratic equation, so what we're going to do is put it in standard form. Okay, so to accomplish that, we have to move 48x to the left side, and we have 2x squared minus 48x plus 216 equals 0. Perfect. Now, one thing you notice is that 2 goes into all the numbers since they're all even, so we can reduce this equation by dividing every single term by 2. So your final answer is going to be x squared minus 24x plus 108. Okay, that's not a final answer. That's just the equation in simplified form. Okay, let's go ahead and solve this. Let's see if factoring works here. Okay, so we're going to use our x game to test it out. So we have AC is 108 and B is negative 24. You can do B squared minus 4AC to see if you get a positive perfect square. What I'm going to do is I'm going to use method of exhaustion. Okay, I'm going to generate all the pairs that multiply to give me 108 and see if any of them add up to give me 24. Okay, so 1 times 108, that clearly doesn't work. 2 goes into 108 54 times. By combining these two, I can either get 52 or 56. That doesn't work. 3 goes into 108 30 power 1, 36 times. This gives me 33 or 39. I'm looking for 24. That doesn't work. 4 goes into 108. 4 goes into 10, 2 carry 2, 28, 7. 4 goes into 108 27 times. Combining these two, I get either 31 or 23. Oh, that was close. But that doesn't work. We're going to move on. 5 doesn't go into 108 since it doesn't end in 5 or 0, the last digit. Advance to 6. 2 and 3 goes into 108, so 6 better go. So 6 goes in there 18 times. If you add these two, you get 24. Perfect. This is the pair that we're going to be using to factor our quadratic equation. Okay, so 6 and 18, the sum has to be negative, so that means both of them are negative, and the product has to be positive. So we have x minus 6 times x minus 18 equals 0. All right, so we set both of them equal to 0. And then solve. So you add 6 to both sides here, x equals 6. And then this one, you add 18 to both sides, and then you have x equals 18. Okay? So it turns out that these are the two answers that we are looking for. Okay, but let's just pick the first one. The length is equal to x, that's equal to 6. So if that's the length, then the width is going to be what? The width is going to be, let's take a look at equation 3. The width is 108 over x. So the width from equation 3 is 108 over x. So we're going to have 108 divided by 6. Carry out the division, you get 18. Okay? All right, so let's state the dimensions of our garden. The dimension, so let's throw dimensions of the garden. Is 6 by 18 meters. Okay, so that's the answer